Okay, so this is the last lesson for Unit 4 on similarity. So of course we're wrapping this up with proofs. And this is the last proofs that we will have for the year. So you can be excited about that. Most of these, again, you're going to start with proving the triangles similar, kind of where in last unit we proved them congruent. So we can begin by proving similar sides or congruent angles. If you're looking to prove similar sides, you'll want to write your proportion kind of within your proof there. If you're proving congruent angles, since similar triangles have congruent angles, you can prove those using common angles, vertical angles, alternate interior, or corresponding. Once you have enough similar sides and or congruent angles, use one of the 3 similarity theorems that we learned in 4.3 to prove that the triangles are similar. Okay, so that is angle similarity, side angle side similarity, or side similarity. Okay, so proving polygons similar, if you have a proof where you're trying to prove polygons, prove that the triangles within the polygons are similar first, and then kind of go from there with what you need. All right, so looking at a few examples here. So we have our given, and those symbols didn't print the best, but it's angle AED, and that should be a congruent symbol to angle ACB. So remember, when they have that given, you want to go ahead and mark that on your figure so that you know what you're working with so far. So AED would be this angle because it needs a vertex of E since it's in the middle. And then the other angle would be ACB, so this one here. So it says that those 2 angles are congruent. And sometimes if one triangle is simply bigger, it may look like that angle is bigger, but it's not actually, remember, it's measuring how wide that opening is, not like the sides or anything. All right, so that's all the information that we have on this, but we're trying to prove that triangle. So let me highlight that. ACB. So ACB is the big triangle, is similar to AED, which is the little one kind of within that. So it is important that the small one is within the larger one because that means they have a common or a shared angle. Okay, so that angle would be angle A, right? And I want to put 2 lines on that to show congruence. Forgot to write given here. Okay, so I'm just going to say, and I can name that as just angle A since there's not multiple angles at that point. So I can say angle A is congruent to angle A, and I'll just say common / shared angle. You don't have to put both of those, just whichever one you're most familiar with stating. All right, so now that means that we already have 2 angles within those triangles, so that is enough to prove them similar. So I would say my given triangle ACB is similar to triangle AED, and since we use 2 angles, that would be angle similarity. All right, number 2. So our given here is that ED is parallel to CB. So I'm just gonna, I marked that on my picture. Remember, parallel is with the 2 arrows. I'm just gonna write up here. So if given parallel, you can use corresponding or alternate interior angles, which are congruent. So that is why the parallel is important. It does not mean those lines are congruent, or it doesn't just automatically tell us angles are congruent. It means that we can use corresponding and alternate interior to prove congruent angles. So working from there, you can start with the corresponding or also interior, if you have those, or you can see if you have a shared. I usually start with a shared angle because again, I have this A at the top. I'm actually going to go ahead and highlight those two triangles again. So they want us to prove triangle AED, which is the top one. If you have colored pens, pencils, highlighters, etc., those are helpful again for this lesson like we did on the last unit. And similar to ACB, which is the big one. So like I said, I usually pick out the shared angle first. So angle A is congruent to angle A because it's a shared angle, meaning it's just within both of those triangles. So that gives me one angle already. If they didn't give you any information about the sides, you pretty much know you're going to have to use angle-angle similarity, okay? Because we don't have anything to work with. We have no measurements whatsoever regarding the sides. All right, from there, there's a couple directions you can go that would both be correct. Since you only need two angles, you could either pick E and C or B and D, okay? But you don't need to pick both. So I'm going to pick E and C. That's just kind of what I found first. So angle E is congruent to angle C. And the reason would be they are corresponding angles. Okay, hopefully you remember this, but it has been a while. So corresponding, if you have two parallel lines, which they told us was ED and BC, and then you have what's called a transversal. So that's the line that cuts through and touches both of them. So corresponding angles, I'll draw a little, are in the same location, but on the other line. So like on this, on ED, we have the angle E is right here. And then on C, it's also right down here at the bottom, kind of like bottom right. All right, so just same location, other line. So those are corresponding angles. All right, and that is enough to prove our two triangles are similar. So triangle AED is similar to triangle ACB. I'm pulling this directly from my proof. And your reason, anytime you're writing a similarity statement for your triangles, your reason should either be angle-angle similarity, SAS similarity, or SSS, okay? All right. Number 3 has a lot of given information. So go ahead, take a minute and just write all that out, label everything, write the given. By label it, I mean mark it on your picture. When I label BC, since there's kind of a lot of points going on here, I do it like that with the lines. Same thing for FE. Okay, so make sure you have all of that set up correctly. Okay, so couple things you could start with. Since they did give us measurements for sides, we are going to need to set up a proportion here and prove that the sides are similar. But they also told us this bit of information. That symbol means perpendicular. Okay, and perpendicular means they form 90-degree angles. All right, so I'm going to need to go ahead and show that somehow and write it in my proof. So it says that AB, which is here, is perpendicular to BE, which is here. And that means that right here, angle B is going to be a 90-degree angle. Okay, so I'm going to take those lines off, but I'm going to say angle B equals 90 degrees. And I can also say, because it said that BE is also perpendicular to DE, so right here, talking about that. So I can also put a 90 degree at E. So angle E equals 90 degrees. And my reason would just be definition of perpendicular. Okay, next I want to prove that my sides are proportional. So I'm going to take just a second first and highlight which triangles we're looking at. So triangle ABC is a little bit the bigger one, and DEF is this one. Alright, so to prove sides are proportional, we need our proportions set up. In this case, it's going to be our short side. Set up proportion when given sides. Just as if you need a reminder here on how to set that up. So you want to do short side over short side equal to long side over long side. And then both of these on top, I will make ABC. Bottom, I'll make DEF. I can flip that too. It doesn't matter which way that is as long as they're kind of kept the same. All right, so my short side for ABC is 12. I'm going to take 2 lines to do this so I have enough space. Over the short side for DEF is 9. So I'm looking at these two. Okay. All right, and then the long side for ABC is 32. So it goes from here to here. And the long side for DEF is 24. Okay, then to check that those are proportional, I think the easiest way on this one, since 12, you don't automatically know 12 times what? It's 32 maybe. The easiest way is probably to cross multiply. So I'm going to do here and here. So 9 times 24 equals 288. Or, sorry, 12 times 24. And then 9 times 32 also equals 288. So that means that our sides are proportional. So our short side was AB of the bigger of ABC over DE and BC to EF. So means these are proportional. And I can just say like definition of proportional. All right, and then that means I actually have enough here because I've proven that this side, this isn't an actual symbol, I'm just writing this to show you what I'm talking about, that all those two sets of sides were similar, and they have this included angle here of E and D. So that makes it a side, angle, side. So I'm going to write my similarity statement. Triangle ABC is similar to triangle DEF. Side, angle, side, similarity. So again, anytime you write a similarity statement for a triangle, make sure you use one of those 3 similarity postulates. Okay, number 4. So they kind of gave us the statements here and want you to pick out the reasons. Sometimes people set these up with the numbers. We just don't usually do that, but that's fine. So given ABDF, so that is our outside shape here, is a parallelogram, and that BF, which is here, is parallel to CE. So those lines cutting through are also parallel. So that is our given. Of course, we know that. All right, and now they also said on line 2 that AB is parallel to FD. Well, we know that because opposite sides of a parallelogram are parallel. Okay, the next line says that angle ABF, which is this one, is congruent to angle DFB. Okay, and that would be, since these are parallel and this is the transversal, we would say that alternate interior angles are congruent because they are inside the parallel lines, but they're on opposite sides of this transversal or cut through line. All right, next line says, line 4, that DFB is, which is this one that we just looked at, is congruent to DEC, which is right here. So I'm not going to add a second congruent line to that since it included that in that statement. Again, it was the same one. And those are also on parallel lines, but they have now this bottom line as their transversal. So those would be considered corresponding angles. And there's a lot going on here, so it's hard to show you what I'm talking about without rewriting over all my pictures. So corresponding angles are congruent as well. Okay, now we have angle ABF. Switch colors so you can know what I'm looking at, which is this one. So we've already kind of highlighted that one, saying it is congruent to DEC, which is this one. All right, so if you look at line 3 and 4 here, those two lines shared DFB. So what they did here is essentially take this one out and say that ABF is congruent to DEC. All right, that is a throwback for sure on a property that we used. If they were given 3 like we were, because this one, that was the same one, and this is the transition between those two being congruent, okay? That property, anytime you have 3, is called the transitive property. All right, and last angles here. Angle A, and this is a new set, so I want to do 2, is congruent to angle D. And we would just say that is because opposite angles of parallelogram are congruent. Sorry, my slide clicked and I had to fix that. So, and last bit here, we are looking at triangle FAB. So that is this top one here, trying to prove that it's similar to CDE. So the bottom one. So hopefully you can look and see which similarity postulate we're going to use here, because I've identified 2 congruent angles within there that makes this be angle-angle similarity. Okay, and that is the last one for today and the last lesson of this unit. So please make sure you are getting your homework in. By the time I come back, it's going to be probably either right at or past the test. So please make sure you're getting caught up and doing that on your own. Okay, I'm going to try to reach out to some people and parents today and remind you that those things need to be turned in. All right, have a good day.